Good afternoon. Today we're going to talk about how one can translate from Agilent's ADS layout into HFSS. And the way we're going to make this translation is we're going to export Gerber data from Agilent, import it into a program called NETEXG by Artwork, and NETEXG will process that data and export an Ansys neutral file, which can be imported into Ansys Designer or into SI Wave or other tools. So what you're looking at right now is the top Gerber file and the top drill file for this multi-layer board we're going to convert. You can see it's mostly plain areas, a few things that look like traces but actually are just plain areas, and a number of round pads, and then the vias are Gerber flashes. And so the circuit actually has 7 layers. We'll be converting all 7 layers and 6 drill layers. And we'll be creating a fairly intelligent ANF file. It'll include padstacks for all of your vias, and it'll include everything sorted out by net. Let's see what we're starting with. I've collected all of the Gerber files and all of the vias into one layer, and I've created an output directory for my results and a working directory for temporary files. Now we'll start up NETEXG, and what we do basically is to load up our Gerber files in the same order as they appear in the stack up. You do that simply by clicking and loading the file like that. So we'll repeat that for the rest of the files. Now we'll define there to be dielectrics between each metal layer. Now we'll assign properties. We'll set the thickness to 0.01, gold, and we'll do the same for the dielectrics. Now we'll go to the drills, and we'll load the drill layers just like we loaded the other layers. And now we got to tell the program which stack-ups they pass through. So the first guy will pass through 1 through 3, then 3 through 5, then 5 through 7, then 7 through 9, 9 through 11, 11 through 13. For the output, we'll select ANF, we have a name, and in this case we'd like to define a little window so that we don't get the text. So we'll define our window to go from there to there, and that'll leave out all this text that we don't want to see. We don't want this text down here, so we've selected the window there. And now all we have to do is press execute. It'll take a few seconds to process this all. Now we're done. Now let's see what we have in the Ansys viewer. I'll do a file import, ANF. There's the file we just created. Notice that we have many multiple nets. Now what you can see here is that we actually have different kinds of entities. Wherever we found a flash and a drill coincident, we actually built a pad stack. So you can see we have the via that goes from M1 to M3 there. All right. And then we also have the plane on M1. If we turn off the vias and the pads, we'll see we have a number of planes, and what we now have where we didn't have before is we've been able to implement the round parts of the plane by using the arc command, and in that fashion we don't generate a lot of excess points. You can see that there's some arcs there in that guy. Same there. So we've come up with a fairly compact, minimal file that also retains a lot of intelligence in terms of nets and padstacks and vias. Thank you.